So 7.2 is another Lagrangian problem. It says write down the Lagrangian for a one-dimensional particle moving along the x-axis and subject to a force F equals minus kx. Find the Lagrange equation of motion and solve for it. So our position is still x equals x, and our velocity is just x dot equals x dot. Now, our kinetic energy is just 1/2 m x dot squared. That's our velocity squared. And our potential, this is a little different, but we have a force equal to minus kx. Now, one thing to keep in mind is F equals negative del u, or the gradient of u. Okay? And in this case, we're given a force. So you can also think of this as u, or potential, is negative the integral of f, or negative the integral of minus kx dx. And u is then just 1/2 kx squared. Okay. And we could say we integrated, let's just say from x naught to x, but actually better yet, we could think of it as integrating a constant, but we can drop the constant with our potential. So then the Lagrangian is kinetic minus potential. So it's 1/2 m x dot squared minus 1/2 kx squared. So that is our Lagrangian. That's part of what they wanted. That's that part. For the equation of motion, it's only moving in the x direction, so I'm only going to do x motion here, which means dl by dx minus d by dt, dl dx dot is equal to 0. It's supposed to be a dot. dl by dx is minus kx minus d by dt m x dot equals 0. And we get minus kx minus mx double dot is equal to 0, or minus kx is equal to mx double dot. And we could say x double dot is equal to minus k over m times x. Now, you've probably seen this a lot. I know I've worked similar ones like this out on the channel before, but we have a function, second derivative of this function, and that is equal to the function times its constant. So this is actually simple harmonic motion. And the solution for that, a general solution, x as a function of time, is a sine omega t plus b cosine omega t. Omega is obviously the square root of k over m. I actually don't think that matters because they didn't ask for it. They did not. So actually they just wanted, I think, up to here. Okay. So that's a pretty straightforward problem. Hopefully that helps a little bit with the process.